Friends, today I am going to teach you about Newton's three laws of motion. Many scientists are keen to know that why an object moves. I take this table, just push it, why it moves. I push it, why it moves. I take this tool and push it, why it moves. Why every object in the universe on applying a certain force moves. There were no laws for it. But after a great scientist Newton founded three laws of motion. What are they? I am going to show you in detail about it. So friends, let us see. Newton's first law of motion was that an object would be at rest or continue to be in uniform motion in a straight line until an external imbalance force is applied on it. This was also commonly called Newton's law of inertia. Before going deep into it, what is inertia? Inertia is laziness, if we have to convert it into simple words. Now I will go deep into it. Now I will try to push this back. I was not able to push this. Why was it so? I said you that inertia is laziness. It is laziness of object. This object did not want to move. Any object in the universe did not want to move. This was concluded by Newton. Now, on the other hand, when I try to push this table, this table was pushed. Why was it so? Bed was not pushed and this table moves. But this table stopped. Would it stop if it would be in space? It would not. The new basic law was every object wants to stay as it was. Means a moving object never will try to gain stability. It will always move. But ununiform means the force exerted by air, by the grip on the land, friction, and etc. These all things were against that table which was moving. Therefore, that table stopped. But if that table would be in space, it would not stop because of a simple reason that there would not be a force. So Newton now concludes that an object would be in same motion or in rest as it was before. So first law of Newton was this. Now I will go deep into the second law of motion. Law of Newton stated that about how much velocity the object will gain. In that law, he simply says that the whole velocity will be directly proportional to mass and acceleration. Means he gave force is equal to mass into acceleration. F is equal to ma. This was about the second law of motion. How it was practically. Suppose this swing, I just try to move this swing without a certain weight. It freely moves. But now imagine if I kept 2000 kilo here, then will this swing move? No, it would not. This was the second law of motion. Mass, which it is directly dependent on mass. If the mass is more, then the force required will be more. And if the mass is less, the force required will be very much less. Now, I told you F is equal to ma. Now, how about acceleration? Now, the mass is kept constant. Just I try to push this swing by like this. It will move like this. But now, on the other hand, I try to push this swing hard. It will move with a greater velocity. Force equal to ma. In the first experiment, I changed the mass by keeping the force applied same. But now, I keep the mass constant, but force applied different. So these two experiments prove that force is directly proportional to mass and acceleration. So friends, Newton's second law clearly stated that F equal to ma. Now I will go in deep into the third law, which is every action has equal and opposite reaction. So friends, let us see. This cycle cannot move without the third law of motion of Newton. When that cycle goes forward, this tire pushes the earth backward, and earth exerts the equal and opposite force on this tire, and hence the cycle is moved forward. So now you will think, what about the earth? But now compare it to the second law. The earth's mass is very more, therefore it has no effect on earth. But as the cycle's mass is very less, it gains the opposite force and it is pushed forward. Now I will show another experiment about this. Experiment is of ball experiment. Just if we take a ball of any kind and just we put it downward, it's come up. Why this came up? It is because when this ball was pushed down, it exerted a force on earth. Force shamely diffused this ball, and this ball was upward. Each action is an equal and opposite reaction. This ball's reaction was putting downwards, but the earth with an equal force pushed the ball upwards. Same reason why earth did not affect, because earth has huge mass. Therefore, it does not create any effect on earth. But earth exerts the same force, that is how ball comes up. This was another experiment. Now, these were the three laws of motions. You notice that all the three laws were related to each other. But it is common sense that all the laws of motion, therefore they will relate with each other. But these laws gave the whole world a relaxation, because many scientists were keen to know that why an object moves in a particular force or direction. So, thank you friends for watching this video. Please subscribe my channel and please comment me for more types of videos. If you want to learn about any science topic, comment in the comment list. Thank you friends. Have a nice day. Bye.